Hello everyone. So in this video, we are going to see this question, and in this question we have one RLC circuit, and you have input V in a T, and you have to calculate this output voltage, and you have given one differential second order differential equation that is representing the behavior of this RLC circuit, and the input is sinusoidal. Okay, you have to calculate the V naught of T. Now one can think how to approach this question. Basically, this operating equation is representing the behavior of a second order differential equation. Let me show you how it is representing. Let's say you have one RLC circuit R, L, and C. If you write the KVL equation, you will get these equations, and the I naught of t is you can write as C dV naught by dt, right? So this is your I naught of t, and if you just put down this I naught of t in this particular equations, you will get a second order differential equation that is representing the relationship in between input and output. Okay, the same way this equation is also representing behavior, or you can say it is mapping to a second order RLC circuit. And now you have to, maybe not second order RLC circuit, it can be a second order RL circuit also. We don't know what is there actually, so it is better not to comment on that, but it is definitely representing a second order circuit. Okay, now you have to calculate the output voltage. So how to proceed for that? See, for a RLC network, this is RLC network, and RLC network is always a LTI system. You can consider it as a LTI system because RLC are the linear element. At the same time, if you don't consider any time variance in RLC, practically this RLC will be time varying in nature, but we generally assume it is a time invariant quantity. Like, for example, if you are measuring a resistance by today as 10 ohm, it should not be like it should not change the value 10 ohm after 100 years, but due to aging effect and all, the 10 ohm can change to 10.5, 11 ohms, like that. Okay, so those things and all I'm not considering. I'm considering that it is a linear time invariant system. Okay, now for a linear time invariant system, let's say you have one LTI system with you. For a LTI system, every complex exponential signal is an eigenfunction of this LTI system. That means if you have input x of t is equals to the power j omega naught t, and the impulse response is h of t, then your output will simply become some k into e to the power j omega naught. Let me take one example better. So let's say you have one system. Let's say LTI system. Okay, and the LTI system, it is a LTI system. It has impulse response as y of t, h of t. This is your x of t, and this is output as y of t. Let's say your input output relationship is given by y of t is equals to x of t minus 3. Let your uh, x of t input is equals to the power minus j 3t, j maybe 4t. Let me take a j 4t. Then if you put this particular thing in this equation, you will get y of t is equals to uh, x of t minus 3, right? So in this particular thing, you have to write out t minus 3 e to the power minus j 4 t minus 3, because for x of t, for x of t, the output is, let's say if you have this LTI system, if you are giving LTI input as x of t, you are getting yt, and yt and xt are related by this. So x of t minus 3. So if you are giving e to the power minus 4, e to the power minus j4t, it is a complex exponential, or it is a complex periodic signal with frequency of 4 radian per second, then the output will be e to the power minus j4t minus 3. So if you write e to the power j3, if you just if you just resolve it, e to the power minus j4t. Now you can see here the relationship between input and output. See, you have given this particular input e to the power minus j4t. Here you are also getting the same term as output with some multiplication factor e to the power j3. So this particular quantity we will be calling it as an eigenvalue of this LTI system. That means that means if I am having a periodic signal, see, this is a periodic signal, it is a cosine, and you can write it into multiple two complex exponential periodic signal by If you split this particular equation in complex exponential Fourier series, you'll be having two complex exponential periodic signal. That means for this signal also, I can write the, or we can apply the eigen function property or eigenvalue theorems for LTI systems. Okay. So what we have to do here, let's say you have this impulse response h of omega in omega domain, and you are giving input as x of t, then your output y of t will simply become, and this input frequency is omega naught, the frequency of xt is omega naught, then the output will simply become h of omega naught into x of t. This is how your things will become. Okay, so same thing we have to do here. Take Fourier transform of this particular signal, you will get j omega, not signal, this is input output relationship between the input and of an LTI system. V naught of omega plus 6 j omega V naught of omega plus 8 V naught of omega is equals to V in of omega. Take the output by input, V naught omega by V in of omega is equals to 1 by minus omega square plus j6 omega plus 8. Okay, so what, let me write down here. So h of omega is equals to V of omega by V in of omega is simply 1 by 8 minus omega square plus j6 omega. Okay, now your input x of t is simply 4 cos 3t minus 30 degree, right? 4 cos 3t minus 30 degree. Now, for example, I am considering only 3t. I will consider 30 degree later because it is a LTI system. So shifting and all you can do the later also. So what is the magnitude? Maybe I can first calculate the total h of omega is equals to, at omega naught. Omega naught here, omega naught is equals to 3 radian per second. So h of 3 I need to calculate, right? So 8 minus 9 plus j 18, right? So 1 by minus 1 plus j 18. So if you see this particular quantity, minus 1 and j 18. So somewhere here this coordinate will become, and so this is the angle you will get. So you can calculate the magnitude 18 square plus 1, and the angle as um, this angle I can easily calculate. So let's say this angle is, maybe I can clearly draw it for you, minus 1 j 18, this is one magnitude, this is 18, and this is, let's say, alpha. Okay, so alpha is tan inverse 18, but we need to calculate angle from this side, right? So the angle from this side will be 180 degree minus tan inverse 18. So you'll be having 1 by 18 square plus 1 is equals to tan inverse 18 minus 180 degree. So this will be your angle. So your output y of t will simply become 4 by over 18 square plus 1 cos 3t plus tan inverse 18 minus 180 degree. But I have calculated the output for this input. But if there is a shift in input, that means 3t minus 30 degree, we have to subtract the minus 30 degree from output also, because it is just a simply time shifting. So there should not be any effect. So you will get, uh, maybe I can do the calculation. tan inverse 18 minus 180 minus 30 degree, we will get cos 3t minus 123.17 degree by 18 square plus 1 over by answer 0.221. So this will be your output. Okay. So this will be your output. So basically it is a mixture of circuit theory or network theory and signal and system, you can say. So in this discussion, if you have any doubt, you can ask me in the chat box. Thank you.